Okay, so we're going to take up more examples of nodal analysis. This particular lecture, I'm going to talk about circuits with dependent sources and circuits with floating dependent sources. So let's do this by way of example. So I have here a circuit. The problem is find the power dissipated in the 5 ohm resistor using nodal analysis. Okay. So first of all, we have how many essential nodes in this particular circuit? How many essential nodes are there? Anyone? Okay, let's see. No? Okay, 3. That's right. No? There are 3 essential nodes. Okay, so this is one essential node. This is, sorry. This is another essential node, and then the whole thing underneath is another essential node. No? So those are 3 essential nodes. So what is the first step in nodal analysis? Okay, you label the essential nodes and you designate one as your reference. So in this particular case, let's designate the bottom node, this whole thing, as my reference. So to indicate that that is the reference, I will put the ground symbol, and then I will label my my node voltages. No? So let's call this node 1, and let's assume that the voltage there is V1, and let's call this node 2 and assume that the voltage here is V sub 2. Okay. So if we have 3 essential nodes, that means we form 2 KCL equations, because you can only form n minus 1 KCL equations when you have n essential nodes. So we have 2 KCL equations. Okay. So let's go ahead and form the KCL equations for node 1 and node 2. No? So for node 1, okay, let me ask for your help here. Can I ask Albert to try to form the KCL equation for node 1? Albert? Albert, are you ready?
Yes, okay. Yes.
Okay.
For node 1 po is V1 minus 20 volts over 2 ohms.
Okay.
Plus V1 over 20 ohms.
Okay.
Plus V1 minus V2 over 5 ohms.
Okay.
Equal 0 po.
Okay. Makalimutan yan, equal to 0. Okay. So that's right, no? That's the equation for node 1. No? Okay, let me ask Tim to give me the nodal equation for node 2.
Okay po, si V2 minus V1 over 5 po.
Okay.
Plus V2 over 10.
Okay.
Plus V2 minus 8i over 2 po.
8i's of t, no? Over 2. Okay.
Equal to 0 po.
Equal to 0. Okay. That's right, no? So these are the 2 nodal equations I have for the two essential nodes, no, that I have labeled. No? And by the way, no, I forgot to mention a step earlier. We know that there are no node voltages here that can be determined by inspection, no? Because supposedly after identifying the essential nodes, we determine whether there are any essential nodes that can be determined by inspection, and in this particular case, wala. No? So we form 2 equations. Now, what's the problem here? The problem here is that you have 3 unknowns. If you take a look at this, you have 3 unknowns. Okay, but is it really a problem? It's not really a problem, because yung isang unknown ko, which is I sub t, can be expressed in terms of my node voltages. No? In fact, can I ask Joseph to tell me what my expression for I sub t will be in terms of my node voltages? No, ito, no? Ano yung expression?
Ano po ulit?
No? Kasi ang problema dito, we have 2 equations, 3 yung unknown natin, ano? Ang unknowns natin V1, V2, at saka ito, no? Okay. But then I can express this I sub v in terms of my node voltages. No? So can I ask you to try expressing I sub v in terms of the node voltages?
Um, V1 minus V2 over 5 po.
Okay, that's right. No, is equal to I sub v. No, so I sub v is equal to v1 minus v2 over 5. No? So actually, this is my third equation. Okay, so in effect, I actually have three equations in three unknowns. And therefore, I can already solve my system of equations. No? Now, typically, if you do this manually, ang gagawin mo ito, ipapasok mo na rito. No? Ipapasok mo na rito sa I sub v. Right? So this one, you replace there. Okay. Now, if I do this, okay, if I solve simultaneously, and I will guess that you will probably ask your calculator to do that for you. You're going to get V1 is equal to 10 volts, and V2 is also equal to 10 volts. Sorry. No, sorry, no, impossible. Just a minute, huh? I'm missing the answer. Okay, sorry, V1 is equal to 16 volts, no? Not 10 volts. V1 is equal to 16 volts. And V2 is equal to 10 volts. Okay. Now, what was the problem? The problem is determine the power dissipated in the 5 ohm resistor. No, so I want the power that is dissipated here. Okay. So what is that? So power in your 5 ohm is equal to I sub v squared times 5. No? Times 5, which is, okay, 16 minus 10 over 5 squared times 5. And if you solve for that power, you're going to get 7.2 watts. Okay. Any question with regard to this problem? Any question? So I think pretty straightforward, no? Itong problem na to. Okay, here's another example, no? This time I have a dependent source, but it happens to be a floating dependent source. Take a look at this. It is a floating dependent source. What do we mean by a floating source? No? Sabi natin, a floating source is a source which connects two nodes, neither of which is the reference node. No? Okay. And the problem with having a floating source is we don't know the current that is passing through that particular source. Therefore, we cannot form a KCL equation for this or a KCL equation for this. No. So what did we study in the last lecture? We studied that when you have a floating source, what you do is you combine the nodes that source connects into a single supernode. So ito ngayon gagawin nating supernode. Okay, now we form two KCL equations, one for V's of A and the other for the supernode. Okay, so what is the KCL equation for V's of A? Okay, I know that you're already experts at doing this, but okay, I will ask another person para lang ma-practice ano. Sino ba hindi pa natatanong? Ses, can you tell me the KCL for V's of A?
For node A po,
Yes,
by
ma'am.
VA minus VC over 8
Okay.
plus VA minus VB over 6
Okay.
minus 3 is
Minus
equal to
3.
0.
Okay, good. Equals 0. No? Okay. Now for the supernode, Clyde, can you tell me what the supernode equation is?
VB minus VA over 6
VB minus VA over 6.
plus VB over 3
VB over 3. Okay.
plus VC minus VA over 8
VC minus VA over 8. Okay.
plus VC over 4
Plus
minus
VC
5
over 4 minus 5.
equals 0.
Okay, good. No? So I think you're all already well versed on getting the KCL equations for nodes and for supernodes. Ano? Okay, again, ang problema, we have three unknowns. Your unknowns are VA, VB, VC, but I only have two equations. Okay, three unknowns, I have two equations. Okay, what is the another equation that I can form? Can I ask Lance, ano yung isa pa equation na pwede kong i-form?
Sir, VC minus VB is equal to 2VX po.
VC minus VB is equal to 2 VX. Okay? Problema, VX is also an unknown, no? So nag-introduce tayo ng isa pang unknown, no? But Lance, can you continue, no? But what is VX?
VX is VA minus VC po.
Okay, VX is VA minus VC, no? So in effect, I now have, pagbilangin mo, I have four unknowns, VA, VB, VC, and VX, but I also have four equations. No? So you should be able to solve this system of equations. If you solve for the system of equations, okay, sabihin ko na lang yung sagot. Okay, you're going to get V of A is equal to 24 volts. V of B is 9.6 volts, and V of C is equal to 19.2 volts. No? But let me just check that. I want to make sure. Yeah, 24, 9.6, and 19.2 volts. Any questions? Any questions? Okay. Okay. This one, I want you to try this on your own, no? Right now. I'll give you probably 10 minutes, no? Let's try about 10 minutes, and then let's discuss the solution to this, no? So as you get your answers, so remember, I'm trying to find the current I1. I want you to use nodal analysis. As you get your answer, can you please enter it in the chat box? Okay, so that I have an idea of who is already finished and who is not yet. So let's do this. Okay. Sige. No one has an answer yet. Okay, I see one with an answer. I will not say whether it is correct or not yet. No. Anyone else? Okay. Sige, no? We can pause here for those that haven't finished yet, ano? For those that have not been able to answer, saan kayo nahirapan? Can I hear where you found difficulty in this problem? Anyone?
Sir, yung pag-identify po ng reference node.
Okay. You can choose any node to be reference node, ano? It shouldn't be a problem.
Okay po, sir.
So, which did you choose? Ano yung pinili mong reference node?
Sir, yung node po sa may 4 ohms and below 2 ampere source.
Ito yung ginawa mong reference node, no?
Apo, sir.
Kasi you notice that this particular problem, you only have two essential nodes, di ba? This one and this one, right? So if I choose this to be reference node, dito ako magki-KCL, right? On the other hand, if I choose the above node to be my reference node, dito ako sa baba magki-KCL. So you can actually choose either of the nodes to be a reference node. It's just a matter of preference, no? It's just that usually pag nakakita tayo ng circuit, may tendency tayo yung reference node doon natin kinakabit sa baba. Okay? So okay. So let's just go through the solution very quickly. Teka, no? Let me see first some others. Okay, si Lance said finding the second equation. Which is the second equation, Lance? Ano yung second equation?
Sir, ano po, instead of the KCL, find, di ba po, two unknowns or two equations po.
Because you can only form one KCL equation, di ba? Kasi dalawa lang yung essential nodes mo rito eh. No? So you can only form one KCL equation.
Yes po, sir. So, yung ano po kasi yung inano po is yung voltage, ay yung node po sa taas yung ginawa, nag-form po ako ng KCL dun po sa upper node.
Sige. So let's just go through the solution, ano? Okay, so let's say ito yung gawin nating reference node. So dito tayo magki-KCL, let's call this point X, no? So my unknown in this particular case is V of X. Yun yung magiging unknown ko, no? The node voltage. And then I have three currents here. I have this current, and this current. Okay? So diyan ako magki-KCL. Okay? So, KCL at X. Okay? This is I1. Notice, itong I1 na to is the same as this I1. Right? This is the same I1. No? So I have I1, okay, plus 2 amperes. No? Itong pababa is 2 amperes. Now let me call this I2. Okay? Plus I2 is equal to 0. I think, Lance, tama ba na yung pinoproblema mo is yung I2?
Hindi po. Ang ginawa ko supernode yung nasa left side.
Okay. You can do that too, no? Sige, gawin natin yan mamaya, no? But that's correct. You can also do that, no? Okay? Okay. So anyway, gawin muna natin itong technique na to, no? So ang pinoproblema natin ngayon dito is yung I2. Okay? Now how do I determine I2? If this is Vx, what is this voltage? Ano itong voltage na to? Anyone? If this is Vx, what is this voltage here?
Vx plus 0.5i po ba?
That's right. That's right. No, very good. No, somebody said 3 volts. Unfortunately, not. No, it's not 3 volts. 3 volts siya kung wala nitong 4 ohms. Right? But remember that there's also a voltage across your 4 ohm resistor. No. No. So you cannot say that the voltage at this point is 3 volts. So be very careful of that. Ano? Hindi porket nakita mo na yung positive ng 3 volt source nakakabit doon, na 3 volts na yan. No? So yung sagot nung isang klase nyo kanina, this is Vx plus 0.5i. No? Because this is a voltage. This is a voltage. Now, if this is Vx plus 0.5i, what is this voltage down here? No, not plus, sorry. Minus. No, not plus. This is minus. Nakuha nyo kung bakit minus? Okay. Sorry, not plus, minus. Right? Remember, this is higher potential, this is lower potential. Okay, so as you're going from here to here, your potential is decreasing, and therefore dapat minus. Okay, if you're going from minus to plus, then your potential is increasing. If you're going from plus to minus, then your potential is decreasing. Okay, did you get that? Kung bakit minus? Okay, so ano yung magiging voltage dito? Anyone? Ano yung magiging voltage dito?
Bali po, ano po, Vx minus 0.5i minus 3 volts.
That's right. No? This is Vx minus 0.5i minus 3 volts. But note that this is now the voltage across your 4 ohms. No? This is the voltage across your 4 ohms. Across the 4 ohms. Meaning to say I2, kasi this is I2, this is also I2. No? I2 is just Vx minus 0.5i minus 3 all over 4. Okay. On the other hand, what is I1? What is I1? I1, madali lang yung I1. Ano? Vx minus 4 over 2. Okay. So I just have a single equation now. No? I have Vx minus 4 over 2, okay, plus, plus 2, okay, plus Vx minus 0.5i minus 3 all over 4 is equal to 0. So one equation, just one equation, one unknown. So all you have to do now is solve for Vx. And you're going to get the answer that was provided by si Albert, no? Now, first of all, I solve for Vx. Vx is going to come out to be 0.73 volts. No? And therefore, I1 is equal to Vx minus 4 over 2. And you're going to get the answer provided by Albert, which is minus 1.64 amperes. Okay. Any question? Okay, may nagsabing he wanted to apply supernode. There's no problem with doing that. No? In fact, some people might prefer to do that. Let's do that. How do I do this? Let me just duplicate this, and then burahin ko na lang. Sorry, having problems. Ganito na lang, no? Okay, so another way, which one of your classmates attempted to do was to use the supernode, no? And you can do that. I can define this to be a supernode. So, okay, but I would have to define this now to be a variable, no? So let's say this is x, so this is vx. Let me call this vy. Okay. So what is now my supernode equation? What is my supernode equation? Anyone? Can somebody tell me my by the way, no? Let's say this is my reference, no? What is my supernode equation? So this is a supernode, no? Sino yung who was the one that tried to make this a supernode earlier? Was it Lance?
Ako po, sir. Yes.
Okay. So Lance, ano yung supernode equation ko?
Ano po? Vy over 4.
Okay, Vy over
Vy
4
over 4 plus 2 po. Plus 2.
plus 2
Plus Vx minus 4 over 2 po.
okay, equal to 0. Right? Tatlo lang naman yung current na associated with the supernode. Ito, at saka ito. No? Okay, tapos ano yung isa equation ko? Kasi, what other equation can I form? What is the relationship between Vx and Vy? Okay, you're going to find that Vx minus Vy, okay, the voltage from this point to this point, that's Vx minus Vy, is just 0.5 I plus 3. I1, sorry, 0.5 I1 plus 3. Okay? And I1 is just Vx minus 4 over 2. So I can just combine those three and I should get exactly the same result as this. Dito ka ba nagka-problema, Lance? Dito?
Yes po, finding yung second equation po.
Itong equation na to.
Opo.
Yeah, oo. Okay. Actually, pag nagkaka-problema ka, you apply KVL, no? Because this voltage here, from here to here, that is Vx minus Vy, no? The voltage from this point to this point is Vx minus Vy. So pag nag-KVL ka rito, this loop, ito yung equation na lalabas. No? In other words, when all else fails, pag hindi na nyo alam kung anong gagawin, you go back to basics. Either you apply KVL or you apply KCL. Okay? So ito nga again, no? So if I apply KVL and I go clockwise, okay? So voltage rise is let's say negative. So this is minus 3 volts minus 0.5 I plus Vx minus Vy is equal to 0, ito lalabas. Okay, so you can do it this way, or you can do it this way. Those are two options available to you. A lot now in circuits, a lot of times you're going to find situations like this. So dapat as you get used to circuit analysis, makikita nyo that you can easily solve for I2 by just computing what the voltage is across this 4 ohm resistor. And the voltage across the 4 ohm resistor is this voltage minus this voltage minus this voltage. And that's, again, that's applying KVL. No? That's also applying KVL. Okay, one last example. No? Recompute for the value of the current I1 if a 1 ohm resistor is placed in series with a 2 ampere source and a 5 ohm resistor is placed across the 4 volt source. Okay? So ang magiging circuit natin dito, I add a 1 ohm resistor, and here I add a 5 ohm resistor. Okay. Note that the number of essential nodes did not change, di ba? Hindi nagbago yung number of essential nodes. Sorry. No, forget that, no. Nagkaroon ka ng dagdag na essential node dito, no? So forget that statement. Okay. But anyway, my question is this, no? Or on your own, no? Can you form the KCL equation for this node with respect to this reference? Please form the KCL equation for this node with respect to this reference. Can someone do that? Any volunteer? Anyone? Sino yung nakakuha kanina ng answer correctly? Was it try to find out, no? Yeah, Albert. Albert, can you form the KCL equation for this node?
Sir, I think
Albert?
yes po.
Ah,
Almost the same lang po nung kanina. Ang magbabago lang po is yung sa side ng 2 ohms.
almost the same kanina. Anong magbabago?
Yun lang po sa side ng 2 ohms.
Anong mangyayari doon sa side ng 2 ohms?
Mama-minus po yung V of X. Kunwari po, V of Y yung sa kabila po ng 2 ohms. Magiging V of X minus V of Y over 2 ohms po. Pero 2 ampere pa rin po yung pababa po niya.
Anong value ng V of Y?
V of Y. 4 volts po bali. Kasi po nakakonect po sa ground node yung
Okay. 4 volts pa rin, no? So may magbabago ba from earlier?
Bali wala po.
Okay, that's what I wanted to point out, ano. If I form the KCL equation for this, it's going to be exactly the same as this, no? As this. Walang magbabago. Walang magbabago. Why? Kasi ito, kahit na may resistor na kabit dito, V of Y pa rin yan. That is still V of Y. Ito naman, kahit na 1 ohm, may 1 ohm dito, ang dumadaan na current dito will still be 2 amperes. Right? So walang magbabago doon sa equation. My equation will not change, no? KCL equation for x will not change. Okay. In which case, the current that we solve for here, the voltage that we get here, okay, and the current that will be flowing here will be exactly the same for the two circuits. So what is the observation here? If I put a resistor in series with an ideal current source, it is not going to change the voltages or the currents outside of that particular branch. No? This resistor is only going to affect the voltages inside this branch. But it is not going to affect the voltages or currents outside that particular branch. Now, the same thing for a voltage source with a resistor across it. No? If I put a resistor across a voltage source, it is not going to change the potential difference between this node and this node. So when you apply your node voltage method, hindi magbabago yung potential difference between this node and this node. No? And therefore, the currents flowing here, no, and here will not change, and then the voltages throughout the rest of the circuit will not change. Okay. The only thing that will change is the current that is supplied by this 4-volt source. Just like the only thing that will change here is the voltage across my 2-ampere source. So that's an observation for when you put a resistor in series with a current source, or a resistor in parallel with a voltage source. Okay. So in this particular case, I1 is not affected by the 1 ohm resistor and the 5 ohm resistor. Okay, that's actually my last example. No, and in this particular example, I just wanted to illustrate that fact, no, because it's not very obvious. Are there any questions with regard to the node voltage method or nodal analysis? Any questions? Okay, so if you have none, that's all I have for this afternoon. Okay, you have more time to work on your quizzes and on your problem set. If any question comes to mind after this session, you can just email me, or you can post a query in Oovle, and I will make it a point to answer as soon as I can. So I'll close the session as soon as everybody leaves. That's all. Thank you.
Thank you po, sir.
Thank you po, sir.
Sir, can I stay po? My
Sure,
question
no problem. No problem.
for the problem set po.
I will just stop recording.
Okay po, sir.